Alright, now this video is going to be a 6G on a 12-inch carbon TIG route using a 1946 Lincoln SA200. The machine I have is very identical to this machine here. The dog chain and the hand crank start, no remote. It is the white machine that I'm using. It's 1946, so it's a 71-year-old arc. And I have older machines. This is GRB College of Welding. I've been going here since November 2008. This is where I go to learn how to weld, and I'm always going back here. And the carbon stainless course I also recommend. If you're taking that course, you may as well also take the Inconel. Reason being is because sluggish metals, you'll come across, say, like a chrome 9, or a stainless 317, duplex. You can use the same techniques that you learn on the Inconel and cover it over those sluggish materials. And if you're welding the Inconel and taking that course, you may as well also take the titanium course so you can learn about heat input, controlling heat input, techniques for heat input, purge quality, parts per million of oxygen, shielding the deposit of metal, techniques for that, cleanliness and oxide removal. And if you're doing the titanium course, you may as well also take the aluminum course, because the oxides and removing the oxides and cleanliness of the aluminum will also carry over to the titanium. And if you're welding those particular metals, then they will cover how to weld the other metals, basically. Like the theory and the knowledge that you learn on those two metals, you can take over and use on the other metals, including the weld techniques and such. Now essentially what I'm looking through here is I'm looking inside the pipe and I'm looking at the weld puddle. And this is just a technique. There's a lot of welding techniques. I'm looking at the weld puddle. I can see I'm using a shade 8 lens. I can see the amount of buildup the weld puddle. I can see the formation. I can see depth perception. I can see if I'm catching any missed edges, mismatch. I can see quite a lot of things looking at the puddle this way. However, I do not use this technique on certain metals, especially metals that have lower inner pass temperatures, say 175, 200 Fahrenheit, because I feel that this technique will overheat the material, and that's kind of how you see the weld puddle, is that it kind of heat soaks and saturates. So you gotta figure out different techniques to use, and I'm just trying to say that I'm not a one-trick pony that uses only one technique on everything. I use multiple different kinds of techniques. So essentially, even though I do not have arc shots on the video, it's more important watching what I'm doing here. Right here, I'm just running the grinder through. I'm prepping the gap, making sure the gap is consistent. If the gap is consistent, my weld bead will be consistent with. Also, my filler metal will not get caught up if the gap closes up, say. I prepped the start. Because when you snap out the TIG torch, you'll have a little pinhole, and it's a solid mass of metal, and it requires X amount of welding current and a certain amount of time to turn that solid mass, the start, from a solid to a liquid. If you thin it out a little bit, it will cut down on the amount of energy and amount of time it turns from a solid to a liquid, and you can commence with your root pass. Otherwise, with carbon steel, because the internal is not purged normally with inert backing gas, you can purge carbon steel, especially if you have a difficult weld that has, say you're dealing with porosity or it's a bad spot, get a lot of wind in the atmosphere or other, you can purge carbon steel. But when you heat up the carbon steel pipe, like the weld puddle, if you heat up the weld puddle and you pause for 5 seconds, say, it doesn't take very long, the atmosphere will rush into your weld puddle. You'll see little miniature fireworks first. the weld puddle will start to boil, and then you'll start to see a lot of sparks, like little fireworks just blasting off, and that's porosity. You also watch the weld puddle start to bubble. So thinning out the starts will cut down on the amount of time it takes to turn it from a solid to a liquid, and you can commence getting that filler metal in there really quick. Take a look at the pipe here. It's a 6G. It's a 45-degree angle. Tilt your head to the left. If you tilt your head to the left, the weld pipe now appears visually as a 2G horizontal weld. If you use the same techniques that you use to do a 2G horizontal weld, you can apply those techniques to this 45-degree pipe, the 6G. Tilt your head to the right. It looks like a 5G vertical up position weld. If you weld this pipe looking at it as if it is a 5G vertical up position weld, you can use the same techniques you would use on a 5G vertical up position weld to apply this, or to weld this 6G 45-degree angle pipe. Depending on the way you look at it, you can change the way you look at the pipe, and you can weld it with the technique that you use. Right now I'm kind of angling my head, and it appears as if it is a horizontal weld. So sometimes you'll see I keep angling my head, looking at the puddle a different way. I'm changing how I look at the weld puddle. If you notice, I'll weld from 6 o'clock to say 3 o'clock, 2 o'clock, around there, depending on the size of the pipe and such. I'll go on the opposing side of the pipe to do the top section. I'm not, when I do the top section on the pipe here, I'm not going to be on the same side of the pipe and try and reach over and try and weld. I'll just stop, I'll go around the pipe, and now I can pull the weld puddle towards me. I do the very same thing on vertical up position welds. I'll just walk over to the other side of the pipe, and I'll just weld the opposing side of the pipe, pulling the weld puddle up towards me. It's a lot better visually. It's a lot easier to weld this way. Now these 2G and 6G, the 6G is just kind of like it's basically just a modified 2G horizontal weld. That's basically all it is. On these positions, you're always adding filler metal to the top bevel. Gravity will pull it down. If you watch what I'm doing here, it's a very, very simple technique. I'm just kind of going up and down from bevel tip to bevel tip. Basically adding filler metal always to the top bevel, and I just kind of bring it down to the bottom bevel. Essentially it's just like an up and down, up and down. I've seen some guys do like a C formation, which is no good. Just keep it very simple. When it comes to these welding techniques, when it comes to practicing and figuring out these welding techniques, figure out the intricate mechanical parts that make up the welding technique and try and simplify them. Now this is the root pass. With this root pass, originally in the video, I was going to do a root pass, a hot, a fill, and a cap pass. And the hot, fill, and cap pass were going to be done with 7018. I filmed that looking at the video immediately before doing the cap pass. Any footage I shot with 7018 arc welding, you know, the stick welding, was no good. It's too bright, bad camera angles. I cut out all that. So all you see in this video is only the TIG root. However, you see a TIG root that has a hot pass, a fill pass over top of it. That changes the appearance of the weld. This weld right here, I also buffed it. I put the buffing wheel inside the pipe and I buffed it to clean up just to clean up the root pass for better visual. Also, I'm zoomed right in. You can actually pause the video, pause it and inspect the root, pause it and inspect the root. You can also put it on the gear setting. There's a little gear there on your YouTube browser if you're using a desktop. You can change the speed of the video. I think you can go to like 0.2 or 0.5. You can speed up the video. You can do a lot of different things. You can also change it to I think it's 780, 1080, high definition. Quite often YouTube uploads my videos here in like a 320 format or something. It's very blurry, very poor. This is just another shot of the same root pass. At this particular angle, it's a little bit difficult to see the amount of buildup. Essentially what you're seeing here is just the width of the deposited metal, the root pass. It's a little bit difficult to see buildup. That's why I've shown the previous weld at a different angle, so you can tell that it has buildup. But this is just a different camera angle, and this it restricts certain things that you can see, which the other